InSight. It's not a rover, it's a lander. This robotic explorer touched down on Mars, on a mission to study the planet's deepest secrets. InSight's goal? To help us understand how rocky planets, including our own Earth, formed billions of years ago. Unlike rovers that explore the surface, InSight stayed put. It became the first Martian geologist, listening to the planet's internal heartbeat and taking its temperature. This mission was all about looking deep inside Mars to unravel its hidden history. InSight's findings have surprised us, challenged our assumptions, and opened up new avenues of research about Mars. It's a testament to the power of exploration and the thirst for knowledge that drives us to uncover the cosmos's mysteries. The red planet, once a distant and enigmatic neighbor, is slowly revealing its secrets, thanks to pioneering missions like InSight. InSight's journey began on Earth, launching from Vandenberg Air Force Base in California on May 5, 2018. This was a special launch for NASA, as it was the first interplanetary mission to take off from the West Coast. After cruising through space for almost 7 months, covering over 300 million miles, InSight finally touched down on Mars on November 26, 2018. Its landing site, Elysium Planitia, was carefully chosen, a flat, smooth plain that offered the best chance for a safe landing. The landing was a nail-biting experience for scientists and engineers back on Earth. Everything had to go perfectly, and thankfully, it did. InSight touched down gently, marking a major triumph for NASA and the future of Mars exploration. With InSight safely on the Martian surface, the real work could begin, unraveling the secrets hidden deep within the red planet. One of InSight's most important tasks was listening for Marsquakes. Just like earthquakes shake our planet, Marsquakes are tremors that happen on Mars. These quakes might be subtle, but they carry valuable information about the planet's interior. To detect these Martian rumbles, InSight carried a super-sensitive seismometer called SEIS. This instrument, placed directly on the Martian surface, could pick up vibrations as small as an atom. And listen, it did. InSight detected hundreds of Marsquakes, giving scientists a peek into the Martian underworld. The strength and frequency of these quakes provided crucial clues about the planet's crust, mantle, and even its core. These Marsquake measurements were a game-changer. They allowed scientists to create a three-dimensional picture of Mars's interior, something never done before. Data from InSight's seismometer painted a fascinating picture of Mars's internal structure. The crust, the outermost layer, turned out to be thinner than expected, perhaps made up of 2 or even 3 sublayers. Deeper down lies the mantle, which, unlike Earth's mantle, seems to be relatively consistent in composition. This finding suggests that Mars might have cooled down more quickly than Earth after its formation, leading to less internal mixing. And then there's the core. InSight revealed that Mars has a large liquid metal core, mostly made up of iron and nickel, but with a surprisingly large proportion of lighter elements like sulfur. This discovery has significant implications for understanding how Mars's magnetic field, which protects its atmosphere, evolved over time. By mapping Mars's interior, InSight has given us a deeper understanding of how rocky planets, including our own, formed and evolved over billions of years. Section 5. Measuring Mars' internal temperature. InSight wasn't just listening to Mars, it was also taking its temperature. The lander carried a special instrument called the Heat Flow and Physical Properties Package, or HP3, nicknamed the Mole. This self-hammering probe was designed to burrow 16 feet beneath the surface and measure the heat flowing from the planet's interior. This heat flow data would help scientists understand how active Mars is geologically, and how much heat is still trapped inside from its formation. Unfortunately, the mole encountered unexpected difficulties. The Martian soil turned out to be much harder and clumpier than anticipated, preventing the probe from reaching its target depth. Despite valiant efforts by the InSight team, the mole couldn't dig deep enough. However, even though the mole didn't reach its full depth, the data it collected provided valuable insights into the thermal properties of the Martian soil, contributing to our understanding of the planet's surface environment. Section 6. Mysteries remain, unanswered questions about Mars. While InSight's mission was a resounding success, some mysteries about Mars still linger. For example, scientists are still trying to understand why Mars's volcanic activity, evident from its massive volcanoes, seems to have ceased long ago. Another puzzle is the nature of Mars's ancient magnetic field. While InSight provided clues about the core, the exact mechanisms behind the planet's lost magnetic field which could have once protected a thicker atmosphere and possibly even liquid water on the surface, remain elusive. Furthermore, the search for evidence of past or present life on Mars continues. While InSight's mission wasn't focused on finding life, its findings about the planet's interior and geological activity provide crucial context for future missions searching for signs of Martian life. InSight's mission might be over, but the quest to understand our red neighbor is far from finished. Each mission, each discovery, brings us one step closer to unraveling the secrets of this fascinating planet. Section 7. InSight's legacy, paving the way for future exploration. InSight's mission, though now concluded, has left an undeniable mark on Mars exploration. Its groundbreaking discoveries about the planet's interior have revolutionized our understanding of Mars's formation, evolution, and its place in the solar system. The data collected by InSight will continue to fuel scientific research for years to come, helping to answer fundamental questions about rocky planets, including our own Earth. The mission's legacy extends beyond its scientific achievements. InSight has shown the incredible capabilities of robotic exploration and the power of international collaboration in space exploration. The mission has inspired a new generation of scientists and engineers, pushing the boundaries of human ingenuity and exploration. InSight's journey may have ended, but its impact on our understanding of Mars and the solar system will continue to resonate for generations to come. Section 8. Conclusion. A new understanding of our planetary neighbor. InSight's mission to Mars was a journey of extraordinary discovery, revealing the hidden secrets of a planet that has captivated humanity for centuries. From listening to the faint rumbles of Marsquakes to peering deep into the planet's core, InSight has provided us with an unprecedented glimpse into the heart of Mars. Its findings have rewritten our understanding of how rocky planets form and evolve, offering valuable insights into the processes that shaped our own Earth billions of years ago. While InSight's mission has come to an end, its legacy will continue to inspire future generations of scientists and explorers. The data it collected will fuel research for years to come, unraveling further mysteries and paving the way for future missions to the Red Planet. InSight has shown us that Mars is not a dead, desolate world, but a dynamic planet with a rich and complex history, a history that we are only just beginning to uncover.